Paper of the day is CPU and cache efficient management of memory resident databases. It's a 2013 paper. Memory resident database systems have to be optimized for two resources, CPU cycles and memory bandwidth. To optimize for bandwidth in mixed OLTP OLAP scenarios, the hybrid or partially decomposed storage model, PDSM in short, has been proposed. However, in current implementations, bandwidth savings achieved by partial decomposition come at increased CPU costs. To achieve the aspired bandwidth savings without sacrificing CPU efficiency, paper combined partially decomposed storage with just-in-time compilation of queries, thus eliminating CPU inefficient functions calls. Since existing cost-based optimization components are not designed for JIT-compiled query execution, they also develop a novel approach to cost modeling and subsequent storage layout optimization. Their evaluation shows that JIT-based processor maintains the bandwidth savings of previously presented hybrid query processors but outperforms them by 2 orders of magnitude due to increased CPU efficiency. Paper did their evaluation based on 3 different benchmarks. The first, the SAP sales and distribution benchmark that was used to benchmark the high-rise system. Paper considered the schema relatively generic in the sense that it supports multiple use cases and covers business operations for enterprises in many different countries with different regulatory requirements. The CH benchmark, a merge between TPCC and TPCH benchmark, modeling a very specific use case, that is the selling and shipping of products from warehouses in one country. Third, a custom set of queries on the CNET product catalog dataset designed to reflect the workload of such a product catalog web applications. Due to the variety of attributes of the different products, we consider the schema very generic. The paper has 3 main contributions. The paper presents the design and implementation of PDSM-based storage component for Hyper, their JIT-based database management system. Second, the paper introduces a novel approach to query cost estimation and subsequent storage layout optimization for JIT-compiled queries, treating a generic cost model like a programmable machine that yields holistic query cost estimations using an appropriate instruction set. Third, authors conduct an extensive evaluation of their system using existing benchmark and compare the results to those of previously published systems. Coming to PS score, overall the paper is a really nice read, so it gets 9 out of 10 on readability. With 12 pages long, it scores 8 out of 10 on length. Reproducibility and repeatability will be a little challenging, so it gets 8 out of 10. Industry value and learning meter is decent, though not very high, so it gets 8 out of 10 on each. Overall PS score is 8 out of 10.